Hi, a couple of people have asked about standard deviation, so I'm just going to run through a couple of questions. This first one is a groups table of data, frequency table, 120 commuters, and the distance that they've commuted in the table. The first question is about estimating the median. Now, I will go through this just for completeness. If we've got 120 people, so we want the 60th person to be the median. 120 is big enough that we don't need to add one and then go between the 60th and the 61st, or we just do the 60th. You could do that if you wanted to. So if we run down through the list here, we've got 10, we've got 29, add 43, we've gone past the 60th, so we know that the 60th person is in here. I'm just going to draw a little comparison bar. On the top I'm going to do the distance, and on the bottom I'm going to do the frequency and find however far the 60th person is through frequency, we're going to go the same distance through the group. But because this is discrete, or I mean distance shouldn't be, but they've rounded it to the nearest mile, which makes it discrete, we're going to have to make it continuous again by doing 0.5. So we're going to start with 19.5 and we're going to go up to 29.5. And on the bottom, and somewhere in here is the value of the median somewhere. And on the bottom, up until this point, we've got 29 people. And then when you add 43 to that, we're going to get 60, we're going to get 72. And we know that where this median person is where we get the 60th person. So obviously I've drawn it in the wrong place, it's far closer to here, but it doesn't matter. However far through this, proportionally through this, the 60 is, we want the same proportion through here. So we want to work out what this distance is as a proportion of the whole, and work out the equivalent distance with the same proportion and add it onto 19.5. So we're going to say 60 take away 29 over 72 take 29. That gives us the proportion that we've gone through this gap here. But we want to scale that proportion to be equivalent to the distance. So we then need to multiply that by the total size of this. So let's say this was a quarter of the way through. Obviously it's not. Then we want a quarter of the way through here. So we do a quarter of that total distance. So that is 29.5 minus 19.5. And that tells us the actual distance there. So then we need to add on to that 19.5 at the beginning. Put all that into a calculator, it should come out with the median. Apologies, some of the handwriting there is a bit poor, but hopefully you followed how to do it and you're not just going to type in what I've done into your calculator. You're going to go back and do it for yourself. Okay, I'll leave that one with you to have a think about. Right, now the next part is actually about the standard deviation. It says the midpoint for each class was represented by x and its corresponding frequency by f, and the midpoint of the lowest class was given to be 4.75. So, right, okay, I think they've specified that because you might be confused about, do I do the 0.5 thing here? You'd have done 9.5, 19, and you've done halfway between that, whereas here it's not so clear. Would you have gone minus 0.5, which probably you wouldn't have. So I think they've given that just to be clear about what they've done. And it just wants to know the mean and the standard deviation. Now, because they've given you these values here, it's actually really straightforward. All we're going to do is we're going to use the formula. Now, in the formula book, they don't give you the version that you want to use here. They give you the square root of sigma x squared over n minus, I think actually they say x bar squared. I think that's the one they give you. So I think they give you this in the formula book. Apologies if I'm wrong on that. So we need to turn it into having sigma f x's, and obviously, well, we could work out the mean first and then substitute it in, but in this case, I don't think we will. We'll just change the formula, because then it just makes more sense. So what is x bar? Well, x bar, the mean of x, is the sum of the x values divided by the number of x values, and then we're squaring that afterwards. But we've got a frequency table, we've got this f, so we need to sneak an f in here, and what we do is we sneak an f in front of each of the x's. So this is going to be sigma fx squared and sigma fx and then squared. I'm going to rewrite it just because my handwriting is getting pretty poor, and we'll have another go. So sigma, the square root of sigma f x squared. Now, to be clear, that is x squared times f, then all added up, but they have just told us, so we just use that number. Now, we're not going to use over n anymore. Not that that would matter, n is the number of items, but we're just going to be clear that the number of items is the sum of the frequency. And we take away from that x bar squared, which is sigma fx over sigma f, which is then squared. Now we have that formula. It's really straightforward to work out the mean. We're just going to work out the thing inside this bracket. We're just going to do this divided by the total frequency, which is 120, and then to find the standard deviation, you're going to put that value in on the top of this fraction. We're going to put sigma f is 120 again, and either you can substitute these in again and just type it all in to your calculator, or you actually know this value now and you can just put minus and squared, or store it as a value, whatever you want to do. If you do type it back in, make sure you put lots of decimal places in if you get lots of decimal places, so that when it gets squared, you're not bringing in errors that's going to make your last decimal point wrong in your answer. Explain why the median is less than the mean for these data. Well, I won't say too much about this, but what you want to do is look up at the table. Remember, the median is halfway through the number of people, and the mean is taking into account everybody's data. When there are extreme values, when there are either very large values or very small values, just one or two very large or small values, then that will drag the mean a lot, whereas it won't drag the median. So just think about where's your median and what are these values going to do to the mean, and that should be pretty straightforward. For a second random sample of 120 commuters travelling to work from a train station in Greater London, the mean distance travelled is this, and standard deviation. Compare the measures of location and spread. So I won't say much about that, but obviously you need to make a comparison. You need to say which mean is bigger, which standard deviation is bigger or smaller, and make sure you put it into context as well. Imagine there's 4 marks there, which is probably quite generous if it was a real paper, real A-Level paper, to actually make the comparison and to make the comparison with a context for the second mark, and then 2 marks for the standard deviation. So again, I won't go into too much detail about that. You can put something in the comments if you want me to explain that a bit more if that's necessary. Second question that I was going to go through is question 4. So here it is. Again, it's the standard deviation question. Data relating to lifetimes to the nearest hour of a random sample of 200 light bulbs from the production line of a manufacturer were summarized in a group frequency table. We don't have that, but never mind. The midpoint of each class was represented by X and the corresponding frequency by F. So they're just covering their back there, just say X is the data, F is the frequency. But here the data was coded using this coding and summarized as below. So remember, Y is the coded data and X is the original. And we want an estimate for the mean and standard deviation of the lifetime. So that's for X. We actually want the real mean and standard deviation for the real data, not for the coded values. So what we're going to do here is we're just going to do it for the coded values. There's no reason why we would decode these into X and then try and do it. That would just be crazy. The whole point of coding is to make life simpler. So using the same formula as before, we're going to find the mean by doing sigma Fy over sigma F. Now sigma F doesn't have a Y in it. That's got nothing to do with whether it's coded or not. It's just the number of light bulbs, so 200. And when you code it, that's not going to change. So that gives you your mean, and then the standard deviation, as we saw before, is the big old square root sigma Fy squared, which is just that value there that we're given, divided by sigma F minus sigma Fy over sigma F, and put that in a bracket and square it. Again, just pop the values in and you've got the standard deviation of the coded value. But that's not what we want. We want the values for the actual data, so we need to decode these. So literally, once we've got the value of the mean, we can just say, well, Y bar equals X bar minus 755.0 over 2.5. Rearrange this formula, times your mean value by 2.5 and add the 755 and you'll get the X bar. Do the same for the standard deviation. So if we get rid of the bars and instead say standard deviation of Y equals the standard deviation of X minus, except you don't decode adds and takes. So I'm just going to cross that out. And it literally is just the standard deviation of Y is the standard deviation of X over 2.5. So multiply by the 2.5 and you get the standard deviation of X. Now, if you're not sure why that's the case, then I'll just draw a quick picture for you. If I've got a load of data here, here's my data. If I multiply that, if I multiply it all by 2, it's all going to get twice as big and it gets stretched out as well. And then if I add something, then that's going to move the data and it's going to move it up. Actually, that's going off screen there. Let's bring it back into view. Right, so I've doubled the data and then I have added something and it's moved it. Well, what's that done to X bar? Well, if X bar was here, well, when it doubled, it got twice as big and then it moved and it's there. So when we decode it, we have to undo everything because everything has happened to that value. But the standard deviation is a measure of spread. And so if we look at it, instead of the standard deviation, let's look at the range. It's a similar measure. It's measuring spread rather than an average. So this spread, when it got multiplied, I don't know if I can click on that. When it gets multiplied, it gets twice as big. So it does grow bigger. But then when you add it, the size of this doesn't change. I can add lots to this or I can take lots away and it doesn't change the value because it's a measure of how far is it between these 2 points. So it doesn't matter where that range is, it's always the same size. Whereas the position of X bar, the higher it goes, the bigger it is. For the standard deviation, it could be 100 minus 90, or it could be 10 minus 0, or it could be a million minus. It doesn't matter what it is, it's always going to give the same value because you're making both the top and the bottom number bigger. And it's the same for the standard deviation, that because it's a measure of spread, when you are coding it, you can add and take, of course, you code the data, that's important, When you decode the standard deviation, you don't do adds and takes, you just decode the times and divides. If there's anything else that you want to ask, if there's anything I've just said which you think is wrong, if I've made a mistake, or if you've got any questions, if you don't know what I'm talking about and you want me to explain it further, then just leave a comment and I'll see what I can do. Thanks very much. Bye for now.